Hello everyone, this is your teacher Marvin and I'm back with another learning episode. Together, we will explore, discover, and enjoy life through Science 9. I know you are all excited for this day's lesson, so what are you waiting for? Get ready as we take off. Intayon! In the previous video, you have learned about one-dimensional motion. Also, you have learned about quantities related to motion like speed, velocity, distance, displacement, time, and acceleration. Kinematic equations were derived to solve problems pertaining to motion and uniformly accelerated motion. In this video, you will learn about two-dimensional motion or simultaneous motion, particularly about projectiles. Here, you will learn about the characteristics and connection between the horizontal and vertical components of projectile motion. Have you ever tried competing with your friends by throwing the farthest stone? Did you win? Is there science behind throwing things? What should you do to get the greatest distance? There is a secret to doing this, which you can understand as we go along today's lesson.
A projectile is an object with an initial velocity and which is then allowed to move under the action of gravity.
Remember, air resistance is present but negligible. It follows a curved path due to gravity, and it must have no motive power on its own.
For example, a cannonball fired into the air. Our projectile now here is the cannonball, and of course, the path of the projectile is what we call the trajectory. And of course, if gravity is not present, our cannonball or the projectile will have a straight path.
Projectiles can be any object being thrown in open air as long it is not blown by the wind. It can be a rock, a ball pen, a chalk, a candy, even your shoes.
Activity number 1. For the first activity, answer the following questions. A. Explain why the following are not considered projectiles. Number 1. A ball resting on the ground. Number 2. A flat paper, not crumpled, being thrown. Number 3. Inflated balloon released in the air. And number 4. A flying airplane. For B, cite 3 possible examples of projectile.
Projectile motion has different features. First, the velocity of a projectile has a horizontal and vertical components,
Where V is your velocity, V sub x is equal to your horizontal component, and of course, your V sub y is your vertical component of the velocity. So let us identify the vertical and horizontal components in this image. So your horizontal component is this one, and of course, your vertical component is this one. And of course, the velocity is this one. So moving on, the horizontal component of the velocity at a given position can be computed by V sub x is equal to V naught cosine theta. The vertical component of the velocity at a given position can be computed by V sub y is equal to V naught sine theta minus the product of acceleration due to gravity and time. And to solve for the velocity at a given position, we can use the formula V is equal to square root of Vx raised to 2 plus Vy raised to 2.
To further understand the following concept, let us have these examples. A projectile is thrown with an initial velocity of 100 feet per second at an angle of 30 degrees above the level of ground. Calculate the horizontal and vertical components of the velocity when the time is 0.
First, let us identify the given in the problem. Our v naught is equal to 100 feet per second, and of course the angle is equal to 30 degrees, and the time is equal to 0. And the physical constant is our acceleration due to gravity, which is equal to 32 feet per square second. So we are looking for the value of our horizontal component, or the v sub x, and the vertical component, which is your v sub y. Solve for the horizontal component of the velocity. To solve for the horizontal component of the velocity, we are going to use the formula v sub x is equal to v naught cosine theta. We just need to substitute our given to the formula. Hence, v sub x is equal to 100 feet per second cosine 30. And you can now use your calculator to compute for the value of v sub x, or your vertical component. And the value of our vertical component is equal to 86.6 feet per second. To solve for the vertical component of the velocity, we are going to use the equation v sub y is equal to v naught sine theta minus acceleration due to gravity times time. We are just going to substitute our given and of course our physical constant, which is our acceleration due to gravity, into our formula. So v sub y is equal to 100 feet per second sine 30 minus 32 feet per square second times 0. And you can now use your calculator to solve for the value of our v sub y. And the value of the v sub y is equal to 50 feet per second. To check if the identified value of the horizontal and vertical component are correct, let's solve for the velocity. To solve for the velocity, we are going to use the formula v is equal to square root of v sub x raised to 2 plus v sub y raised to 2. Since we already identified the value of the vertical component and horizontal component, we are just going to substitute it into our equation. Hence, v is equal to square root of 86.6 feet per second raised to 2 plus 50 feet per second raised to 2. Squaring the value of the vertical and horizontal component, we have now v is equal to square root of 7,499.56 feet per square second plus 2,500 feet per square second. The value now of the velocity is equal to 100 feet per second, which is also the same in the given in the problem. Therefore, the value of our Vx, or the V sub x and V sub y, or your vertical and horizontal component, are correct.
Since you have now learned how to compute for the x component, y component, and the velocity, it's your time to shine.
Activity number 2. Direction: solve the problem. In the sample problem, calculate the horizontal and vertical components of the velocity after 1 second. Also, compute the velocity at this position. For your benefit, the given v naught is equal to 100 feet per second, the angle is equal to 30 degrees, time is equal to 1 second, and of course, the physical constant, which is the acceleration due to gravity, is equal to 32 feet per square second. A. Solve for the horizontal component of the velocity. B. Solve for the vertical component of the velocity. And C. Solve for the velocity.
Another feature of projectile motion is that the horizontal component, or the Vx, of the velocity is constant at any given position. This means that it moves at the same speed along horizontal. Thus, it does not accelerate in this direction.
For example, at position 1, if the initial velocity is equal to 100 feet per second, the angle is equal to 30 degrees, then what is the horizontal component, or the v sub x, at this position? Since we are solving for the horizontal component at position 1, we are going to use the equation v sub x is equal to v naught cosine theta. Substituting the given into the formula, hence, v sub x is equal to 100 feet per second cosine 30. The value of our horizontal component at position 1 is now then 86.6 feet per second. And if you can see on the image flash on your screen, the horizontal component at position 2, 3, 4, and 5 are all the same. It is because the horizontal component of the velocity is constant at any given position. This means that it moves at the same speed along horizontal. Thus, it does not accelerate in this direction.
To test if you fully understood the lesson, let's have this activity.
Activity number 3. Direction. Answer the following question. Please refer to the given on the problem we just had discussed on our example. The projectile is shown in different positions. What is the horizontal component of the velocity in position 1? What about position 2, 3, 4, and 5? B. What do you notice of the values of Vx and why?
Another feature of projectile motion is that the vertical component or the Vy of the velocity changes at every given position. This means that it accelerates uniformly at a rate of 32 feet per square second in this direction.
For example, at position 1, if the initial velocity is equal to 100 feet per second, the angle is equal to 30 degrees, and the time of flight is equal to 0.5 seconds, then what is the vertical component or the v sub y at this position? Since we are looking for the v sub y or the vertical component at position 1, we are going to use the equation v sub y is equal to v naught sine theta minus acceleration due to gravity times time. Substituting the given and of course the physical constant, which is acceleration due to gravity, Vy or the v sub y is equal to 100 feet per second sine 30 minus 32 feet per square second times 0.5 second. V sub y is equal to 50 feet per second minus 16 feet per second. The value of our vertical component or our v sub y now is equal to 34 feet per second.